The following pre-lab video corresponds to one of Monash Science's idea experiments. In this case, it's in the School of Chemistry, and we're going to be focusing on calorimetry. Idea experiments are a bit different to the usual kind of undergraduate experiment. We've thrown away the traditional model of giving you a recipe, and we're asking you guys to design the experiment yourselves. The name idea experiments really comes from an acronym which is derived from inquiry, in other words, asking the right questions, designing an experiment, exploring, in other words, performing that experiment, and then maybe even answering the question that you asked at the very beginning. Sometimes you might find you're a little bit surprised. In this case, we're exploring calorimetry, which is something you've been talking about in lectures. We're going to be using calorimetry to verify components of our special mixture of Monash University baking powder. Of course, this comes from the thermodynamics topic, and in this case, we're going to be looking at temperature change to see if we can make an unambiguous decision about what this baking powder is made of. The first part of this exercise is just going to be to watch your demonstrator perform the reaction that we're going to be exploring. But from that point on, it's up to you to design the rest of the experiment. The idea experiments are always a collaborative process. You work in groups of three or four students. There's a lot of teamwork involved. There's delegating different jobs to different people, and it really takes good organisation to get through the activity in 3 hours. So make sure you're well organised. Baking powder. What are the typical ingredients in baking powder? As a general rule, baking powder contains sodium bicarbonate and an acid or some kind of acid salt. A few examples might be citric acid or tartaric acid, or some of these acid salts such as potassium citrate, monocalcium phosphate. There is a large range of these acids and acid salts. Most importantly, they all react with sodium bicarbonate to give a salt, carbon dioxide gas, and water. The information we have is that our baking powder consists of citric acid and sodium bicarbonate. Some of the questions you might ask yourself are, what ratio do these two molecules react in? Is it a 1-to-1 ratio, or is the stoichiometry different? Have a look at the chemical structures that are given in your lab manual and think about what the chemistry is going on there. Hopefully you've identified that this is an acid-base reaction. So have a think about how the citric acid molecule might react with sodium bicarbonate. That should give away the stoichiometry. Is it going to be an exothermic or endothermic reaction? There might be a few things to consider here. How might you generate a calibration curve that can be used to determine the blend ratio? The Monash Uni baking powder isn't necessarily in the perfect stoichiometric ratio. What's more, are there any other tests that you should consider in order to test the mixture? You might want to think about what the pH of this kind of mixture might be. Lastly, follow the lab manual and the proformas provided to guide your experimental design. If you look on Moodle, you will find that there are 2 proformas. Proforma A must be completed before you arrive to complete the experiment. There are pre-lab questions there, and you won't get the marks for those if you haven't completed Proforma A before arriving. Proforma B should be completed as a group, but it's up on Moodle for you guys to have a look at beforehand. A few quick points about constructing a calibration curve. In this case here, we're going to be looking at temperature change. So we're going to be reacting these 2 molecules together, and we should see that there is a temperature change associated with that. So to make a calibration curve, what we need to do is measure the temperature change for a series of known citric acid and sodium bicarbonate mixtures. You can see here I've got 4 mixtures, and there's a temperature change associated with each of those different ratios of the 2 components. We then plot our data points. And on the x-axis here, you can see I've left the question open. I'm going to leave it up to you guys to think about what the units might be on the x-axis. On the y-axis, you would be plotting temperature change. Put your data points in position, generate some sort of line of best fit, and I'll give you a hot tip. You may not find that your calibration line is a straight line in this experiment. You should probably expect it to be something a little more complex. Once you've got your calibration curve, measure the temperature change of your unknown sample, in our case the Monash University baking powder, and use the calibration curve to estimate the blend ratio of your mixture. Draw your temperature change line across and bring it down to the x-axis to determine some sort of value. Well, hopefully that's enough information to get you going with the calorimetry idea experiment this week. Good luck. We hope you get some sort of positive result.